LiFi technology, a viable potential solution to the global wireless spectrum shortage. The contents of my presentation: introduction, key terms, LiFi components, how LiFi works, presentation by Dr. Haas, LiFi versus Wi-Fi, advantages and disadvantages, the progress and global interest, internet in developing countries, the possible areas of usage, challenges of LiFi, ethical evaluation, and conclusion. Whether you're connecting to wireless internet in a coffee shop or competing for bandwidth in online gaming, you've undoubtedly faced sluggish speeds due to multiple devices connected to the same network. Since the digital age, the internet has become an essential need, but due to heavy traffic, airwaves continue to be congested. Fortunately for us, German physicist Professor Harald Haas developed a solution termed data through elimination, sending data through an LED light bulb equivalently as an infrared remote control, yet more powerful. His invention, titled LiFi, can generate data rates quicker than 10 megabits per second, surpassing your average broadband connection. He anticipates the future when data from smartphones, tablets, and laptops are transmitted via LiFi connection with firm security established. No light equals no data. LiFi is the transmission of data through an LED light bulb. A speedy yet cheap wireless communication system, it is the optimum version of Wi-Fi. At the heart of this technology is a new generation of high brightness light emitting diodes, says Harald Haas. Very simply, if the LED is on, you transmit a digital 1. If it's off, you transmit a 0. They can be switched on and off very quickly, which gives nice opportunities for transmitted data. At the Heinrich Institute of Tech in Berlin, scientists have achieved data rates at high speeds of over 500 megabytes per second using an average white LED bulb. In Las Vegas, this technology was showcased at the 2012 Consumer Electronics Expo using a pair of Casio smartphones to exchange data using light emitted from both screens at a distance of 10 meters. In October 2011, the LiFi Consortium was created by undisclosed technology companies to promote high-speed optical wireless systems while eliminating the usage of the radio wireless spectrum as they exploit a different section of the electromagnetic spectrum. The consortium believes LiFi can achieve more than 10 gigabits per second, allowing an HD film to download under 30. Interestingly, this technology began during the 1990s in countries such as Germany, Korea, and Japan, where it was discovered LEDs could be modified to transmit information. Since LEDs have been retrofitted to transmit data, VLC has become faster, safer, and cheaper than Wi-Fi. Soon, light fidelity will eradicate costly mobile radio masts in which costs range from $200,000 to $250,000. Haas' invention illustrates how these signals are attuned with information embedded within the illumination of the light bulb, sending data via changes within light intensity at ultra-high rates of 100 million cycles per second. Here are some key terms to know. LiFi is a bidirectional, high-speed, and fully networked wireless communication technology similar to Wi-Fi. LiFi is a subset of optical wireless communications and can be a complement to radio frequency communication or a replacement in context of data broadcasting. An LED is a light-emitting diode and is a semiconductor device that emits visible light when an electric current passes through it. The benefits of LEDs compared with incandescent and fluorescent lights include a low power requirement, in which most types can be operated with a battery, high efficiency, where most of the power supplied to an LED or IRED is converted into radiation in the desired form, with minimal heat production, and a long life. When properly installed, an LED or IRED can function for decades. Light is part of the electromagnetic spectrum, which ranges from radio waves to gamma rays. Electromagnetic radiation waves, as their name suggests, are fluctuations of electric and magnetic fields, which can transport energy from one location to another. Visible light is not inherently different from the other parts of the electromagnetic spectrum, with the exception that the human eye can detect visible waves. Optical wireless system refers to the combined use of two technologies, conventional radio frequency, wireless and optical fiber, for telecommunication. Long-range links are provided by optical fiber, also known as fiber optic cables, and links from the long-range endpoints to end users are accomplished by RF wireless. The electromagnetic spectrum is comprised of 7 different forms of energy: the radio waves, microwaves, infrared waves, visible light, ultraviolet rays, X-rays, and gamma rays. Gbps means gigabits per second. Wi-Fi is a networking technology that uses radio waves to provide wireless high-speed internet and network connections. A common misconception is that the term Wi-Fi is short for wireless fidelity. However, this is not the case. Wi-Fi is simply a trademarked phrase that means IEEE 802.11x. A data stream is an uninterrupted flow of a long sequence of data, such as in audio and video data files. VLC, or visible light communication, is illumination and communication, a data communications medium which uses visible light between 400 and 800 terahertz. VLC is a subset of optical wireless communications technologies. The technology uses fluorescent lamps, such as ordinary lamps, not special communication devices, that transmit signals at 10 kilobits or LEDs for up to 500 megabits. Low-rate data transmissions at 1 and 2 kilometers were demonstrated. Bluetooth is a wireless technology standard for exchanging data over short distances, using short wavelength, ultra-high frequency radio waves in the industrial, scientific, medical radio band from 2.4 to 2.485 gigahertz from fixed and mobile devices and building personal area networks. IRDA. The main reason for using IRDA have been wireless data transfer over the last 1 meter using point-and-shoot principles. Thus, it has been implemented in portable devices such as mobile telephones, laptops, cameras, printers, medical devices. And the main characteristics of this kind of wireless optical communication is physically secure data transfer, line of sight, and very low bit error rate that makes it very efficient. Finally, network topology is the arrangement of the various elements, links, nodes, of a computer network. Essentially, it is the topological structure of a network and many to be depicted physically or logically. Physical topology is the placement of the various components of a network, including device location and cable installation, while logical topology illustrates how data flows within a network, regardless of its physical design. The LiFi product consists of 4 primary subassemblies: the RF power amplifier circuit, the printed circuit board, the bulb, and an enclosure. The RF power amplifier circuit has a radio frequency signal generated by the solid-state PA and is guided into an electric field about the bulb. The PCB, or printed circuit board, controls the electrical inputs and outputs of the lamp and houses the microcontroller used to manage different lamp functions. The bulb is the high concentration of energy in the electric field vaporizes the contents of the bulb to a plasma state at the bulb's center. This controlled plasma generates an intense source of light. And finally, the enclosure is where all of these subassemblies are contained in an aluminum enclosure. So how does LiFi work? Well, data from the internet and the local network is used to modulate the intensity of the LED light source in a way undetectable to the human eye. The photodetector picks up the signal, which is converted back into a data stream and sent to the client. The client can communicate through its own LED output or over the existing network. It sends a single data stream of bits at the rate of 10,000 to 2,000 bits per second. Now replace the IR LED with a light box containing a large LED array. This system is capable of sending thousands of such streams at a very fast rate. In this block diagram, the two key processes are modulation and demodulation. These processes help convert light source to data. This is an example of how LiFi works within an office setting. You can see that LED lights are powering different computing devices. For example, the computer, cell phone, laptop, printer, wireless thermostat, and the clock.
Neighbor to the visible light spectrum go to remote controls. You all know the remote controls have an infrared LED. Basically, you switch on the LED, and when it's off, you switch it off, and it creates a simple low-speed data stream in 10,000 bits per second, 20,000 bits per second, not usable for a YouTube video. What we have done is we have developed a technology with which we can, first of all, replace the remote control by a light bulb. We transmit with our technology not only a single data stream, we transmit thousands of data streams in parallel at even higher speeds. And the technology we have developed, it's called SIM-OFDM and spatial modulation. These are the only technical terms. I'm not going into details, but this is how we enabled that light source to transmit data. You will say, okay, it's nice. It's a slide created in 10 minutes, but not only that. What we've done is we have also developed a demonstrator, and I'm showing for the first time in public this visible light demonstrator. And what we have here is an ordinary desk lamp. We fitted in an LED light bulb worth $3, put in our signal processing technology, and then what we have here is a little hole, and the light goes through that hole. There's a receiver. The receiver will convert these little subtle changes in the amplitude that we create there into an electrical signal. And the signal is then converted back to a high-speed data stream. In the future, we hope that we can integrate this little hole into these smartphones. And not only integrate a photo detector here, but maybe use the camera inside. So what happens when I switch on that light? As you would expect, it's a light, a desk lamp. You could put your book beneath and could read. It's illuminating the space. But at the same time, you see this video coming up here. And this is a video, high-definition video, that is transmitted through that light beam. You're all critical. You say, ha ha ha, this is a smart academic doing a little bit of tricks here. But let me do this. Once again, still don't believe? It is this light that transmits this high-definition video, this bit stream. And if you look at the light, it is illuminating as you would expect. You don't notice with your human eye, you don't notice the subtle changes in the amplitude that we impress onto this light bulb. It's serving the purpose of illumination, but at the same time, we are able to transmit this data.
The next few slides show the differences between LiFi and Wi-Fi. In this slide, you will see that LiFi beats all other existing technologies. LiFi achieved at least 10 gigabits per second data speed. On this second table, you will notice another main advantage of using LiFi. In addition to a very high data speed and other metrics shown on this table, LiFi is cheaper. On this third table, you will see the direct comparison between LiFi and Wi-Fi. The greater difference between the two, LiFi is green technology. Here are 10 advantages of LiFi. Higher speeds compared to Wi-Fi, proper security, it has a 10,000-fold bandwidth, very high peak data rates, simple usage and applications, useful in electromagnetic sensitive areas, readily available internet via LED, the avoidance of radio frequency spectrum crunch, enhanced energy efficiency by combining data communication and illumination, complete elimination of health concerns, and net neutrality can be achieved. These are the 5 disadvantages of LiFi technology: compatibility in direct line of sight, the presence of light, low efficiency with regular bulbs, interference, and the high installation cost of the VLC system. As you can see, LiFi has become a worldwide interest. For instance, Mexico developed a VLC system attaining speeds of 10 gigabits per second. China made a breakthrough in LiFi tech with speeds of 50 gigabits per second. Likewise, in Beijing, the Ministry of Industry and Information Technology VLC system attains similar speeds. In Korea, applicants have utilized LiFi to replace wires in medical treatment. They implemented blue, red, and green LEDs to apply parallel transmissions through different channels. This allowed physicians to conduct EEG tests, brainwave study, and ECG tests, electric activity of the heart. As well, Disney has committed resources and expenses toward the approach of VLC. In Shanghai, Professor Chinan used basic items to successfully create her own LiFi. After her success, she was funded by Fudan University and the Shanghai government, spending an estimate of $500,000 on research and construction. Hence, the drawbacks. This includes her project being non-available for portability, as well as for proper accuracy in the transmission of frequencies. Still, it is an impressive feat to learn that many scientists, such as herself, are in the progress to facilitate LiFi. Granted that LiFi will benefit all, it is still a work in progress, but presents opportunities for global connectivity. Here is a special advantage as LiFi as a medium for net neutrality. Now, global mobile data traffic grew 69% in 2014 and continues to grow yearly. Mobile video traffic exceeded 50% of total mobile data traffic for the first time in 2012. About 500 million mobile devices and connections were added in 2014, and in the same year, over 189 million laptops on the mobile network, each generating 3.2 times more traffic than the average smartphone. In the mobile network through 2019, the amount of mobile devices will exceed the Earth's population, and about 75% of global mobile data will be videos. So how can LiFi solve net neutrality? Well, for those of you who don't know, net neutrality is the principle that internet service providers and governments should treat all data on the internet equally, not discriminating or charging differentially by user, content, site, platform, application, type of attached equipment, and modes of communication. Unfortunately, internet service providers treat data and companies separately, even conjuring 2 types of broadband speed lanes: the fast lane and the slow lane. In order to access the fast lane, ISPs compel companies, for example YouTube, to pay premium costs, granting high-speed streaming of HD video and content towards users. But if YouTube did not pay on time, ISPs lag streaming and downloads until further notice. The second lane, namely the slow lane, is essentially for everyone unable to afford the fast lane. So if you decided to launch a YouTube competitor, but are unable to afford the premium costs, already you're at a disadvantage. Consumers and companies alike are against the ISP's 2-tier usage and the facade of the fast lane. It is unfair for the rich to obtain fast internet while the poor obtain slow internet. Even companies refuse to pay high cost for high-speed internet because they believe it ought to be standard for all. With LiFi's very high peak data rates and speed, providing internet access to many is not an issue. It provides enhanced energy efficiency by combining data communication and illumination, and provides complete elimination of health concerns. Remember, it's light energy and not radio frequency. Hence, net neutrality will not be an issue. But net neutrality has become a fairy tale thanks to the U.S. Federal Communication Commission. the FCC introduced a legislative proposal that grants ISPs official action to charge companies for faster lanes. President Obama affirmed that fast lanes ought to be banned. He addressed the FCC to ban paid prioritization and classify ISPs as public utilities. But the internet affects everyone. For internet in developing countries, net neutrality means everything. Take Evelyn, a 40-year-old woman residing in the Philippines whom, like us, accesses social media on a daily basis. She plans events with family and friends, reads the news, or enables the Waze app when driving around Metro Manila. But unlike us in the West, who can pay for unlimited data or access Wi-Fi hotspots, Evelyn's greatest challenge is ciphering which app to open and just for how long. The internet has become a human necessity, but despite America's issue between the fast lane and the slow lane, developing countries continue to run on weak and insufficient internet. Facebook CEO Mark Zuckerberg has addressed the issue via Internet.org, a partnership between companies such as Facebook and Samsung in which they are working together to make the internet and the different parts of it more efficient, for everyone to have access to it for a really affordable price or free is the real goal for basic internet services. While Asia beats the global average on broadband speeds, there is still a huge difference between the accepted and the neglected. Singapore is advanced on an average speed of 118.8 megabits per second, but the Philippines remains at a staggering 3.6 megabits per second. Even worse, Singapore's broadband speeds have doubled in the past year, while the speed in the Philippines only inched up a meager 6%. As of May 2015, the Philippines has the second slowest average download speed among 22 Asian countries, ranking 176 out of 202 countries worldwide. The Philippines also has some of the most expensive internet connections in the world, spending $18.19 per megabit compared to an average of $5.21 per megabit worldwide. It's a similar story in Asia's cellular speeds. China's cellular speed zooms at an average of 27.6, while Vietnam struggles with data rates of 1.9 megabits, essentially a blank white screen. There are 8 possible areas for LiFi usage. For example, when traveling by air, radio frequency has compromised the airplane's instruments. With LiFi, it assures a safe flight with access to your mobile devices. For power plants, they require fast interconnected data systems to monitor demands, grid integrity, and in nuclear plants, core temperature. The savings from proper monitoring at a single power plant can add up to hundreds of thousands of dollars. LiFi could offer safe, abundant connectivity for all areas of these sensitive locations. Not only would this save money related to currently implemented solutions, but the draw on a power plant's own reserves could be lessened if they haven't yet converted to LED lighting. For undersea research, pilots can operate underwater ROVs with a power supply encased within cables. Unfortunately, ROVs struggle with insufficient tether length or become stuck in gaps. If the wires were cut and replaced with light, such as a submerged high-powered lamp, it would be convenient for undersea explorations. The headlamps may be used as communications, processing data autonomously and referring findings periodically back to the surface. And for underground communications, subway stations and tunnels are common dead zones for most emergency comms. But with an LED light augmented with LiFi, you're online. In the medical field, Wi-Fi at hospitals interferes with monitoring equipment. LiFi is the antithesis. And the replacement of Wi-Fi with LiFi at institutions and companies will offer clearer bandwidth and quicker data streams. At traffic signals, we can use LiFi to communicate with LED lights, exponentially reducing car accidents. But despite the possibilities, LiFi faces several challenges. Light cannot pass through objects. LiFi requires a line of sight. Interference from external light sources, such as sunlight, normal bulbs, opaque materials, will cause interruption in the path of communication, the high installation cost of the VLC systems, and how the receiving device will transmit back to the transmitter. But every challenge requires an ethical evaluation. As I mentioned before, LiFi technology will provide a greener, clean, and bright application of IT, potential great use in different areas, enhanced energy efficiency by combining data communication and illumination, and enabling the Internet of Things will resolve net neutrality. So far, there are more than 14 billion LED light bulbs worldwide, and compared to the radio wave spectrum, visible light is 10,000 times available. Wouldn't it be nice to use that light? As I've mentioned about congested radio waves, net neutrality, or insufficient internet in developing countries, I believe LiFi will facilitate these tasks, tackling efficiency, safety, capacity, and availability. My perspective of this topic is ethical, most specifically in effective altruism. Peter Singer believed that all beings are equal, and with today's resources, we ought to utilize and employ ourselves in aiding the underprivileged. As well, Immanuel Kant can agree on the augmentation of LiFi, because once implemented, the imagination of possibilities for its usage are simply amazing. I believe, and so will Kant, that the greater good is done for the majority of the world. In conclusion, LiFi is an upcoming and growing technology with an auspicious future. As visible light surrounds us, this propitious resource can facilitate tasks in fields unattainable with Wi-Fi and other technologies. The possibilities are incalculable. Once patented, every bulb will be utilized as a Wi-Fi hotspot and proceed toward a cleaner, greener, safer, and brighter future.